Hello everyone, this is a screencast based on a talk I gave a little while back. It covers how to get started in the cryptocurrency space as a either developer or an investor without getting involved in too much of the hype. So let's get started. First, a little bit about me. My name is Maddie Shang. I used to be a finance person. I did my CFA level 3, worked in the capital markets, and then eventually worked in venture capital, from where I started to work on my own startups. And in the process, I became a techie. So now I work on JavaScript applications at OKGrow. And we have this cool policy where one day out of the week, we are allowed to explore and work on whatever cutting edge technology we personally are passionate about. So I specialize in blockchain and AI. So this whole thing came about one day when my mom called me and asked me about Bitcoin. She was like, oh, what are Bitcoins? Should I buy some of them? And that got me a little bit concerned because in traditional finance, we say if you hear a barber, your Uber driver, your aunt, all starting to talk about the same stock or the same asset, there's a pretty good chance that there might be some kind of bubble. And I definitely think that's a little bit true for cryptocurrency right now. So I wanted to provide this presentation and give people a little bit of background so they can do their own research and end up on the right side of the market. So the goal of this presentation is to explain it like I'm 5 style intro and tour to cryptocurrencies. Hopefully it will allow you to walk away with more questions to ask and ways to find answers. And it will tell you how to get started either as a developer or from an investor's perspective. What this talk is not about is how to be a crypto millionaire. I think the time for that maybe have come and passed. It's also not about how to build the next ICO, even though it's technically not too challenging. And it's also not going to be a technical literature review. We're not going to talk about too many white papers, but if you're really interested in the space, that's actually a really recommended and really great way to do a deep dive. So let us get started. Cryptocurrencies, well, what are these? So cryptocurrencies are actually applications built on blockchain technology. Bitcoin being the first and most widely known application. These are also currencies backed by mathematics and cryptography, and they are a cheap, fast way of transferring ownership of digital assets. They have the tremendous characteristics of being private, immutable, transparent, and decentralized, and trustless. I know it's a mouthful, but we will cover these characteristics in a little more detail later in the slides. So why are these things good? Why are they cool? What can they do right now? For one, it allows you to send money across the world for cents in minutes. And if you compare it to what is available in a traditional finance system, it will take you probably a week. It will take you at least 10% of transactions, which is definitely not ideal. And even right now, it has the potential or the capability of replacing about 80% of counting procedures and accountants. Because with smart contracts, we can do a lot of automation, and there's a lot of operational efficiencies to be gained. And something even cooler, it allows for better distributed computing. For example, we can now have the ability to decouple AI data, AI models, and computing resources. Let's say someone has data, someone has models, someone has the GPU. You can now coordinate training of models and renting of data and renting of computing resources, just orchestrate it and coordinate on the blockchain without, showing people exactly what's in the model or what exactly is in the data. So very cool stuff. So let's talk about blockchain. Like I said, if you really want to understand cryptocurrencies, it's really helpful to have a basic understanding of the blockchain. So this is where we will start. Blockchain is actually extremely aptly named. It is literally a chain of blocks. So your next question might be, what are blocks and how do they change? So a block is very similar to a box, and this is the analogy we'll continue to use in this presentation. So every node on the network, any participant in the blockchain will have an open box. And what they're listening for are new transactions. So here we see transactions coming into the box, and more transactions will come into the box. And at some point, the box will get full, and we will try to put the lid on the box. And that will be essentially packaged as a block. So the next question is, what exactly are transactions? Well, it's maybe not surprising. Transactions are also in the form of a chain. For your CS inclined folks, you can think of this as some kind of a linked list where there is a pointer reference to the previous transaction. So there are three key parts of a transaction that's critical that helps transactions form a chain. One, we need to know where did the asset come from before it became mine, and before it arrived in my address, where did this come from? So this in a way proves that this asset validly exists. The second thing is I need to tell people where am I sending this asset to. So for that, I need a public address or a public key. And the last part is very interesting and very critical, is I need to somehow prove that I have control and I have ownership of the assets I'm trying to send to someone else that's currently in my address. So let's look at this using a animated example, and we'll restart animation right here. So Bob is trying to send some assets, maybe Bitcoins, to Alice. And Bob and Alice are typical names we use in the crypto field. So I decided to stay with convention. So Bob will have a public address which contains the assets, and it might look something like this. Now Bob needs to tell us which incoming transaction send the assets into his address, which currently contains the asset he's trying to send. And Bob also needs to have a address or public key of the person he's trying to send assets to. And now Bob is going to say, hey, I want to send stuff in this address that belongs to me to this other address, and I can prove that I own this address by using my private key to authorize the transaction. Great, so let's talk about how blockchain, we talk about blocks, we talk about transactions, but how do they chain? Well, to do that, we kind of need to understand the concept of a cryptographic hash. So I'll start the animation again. Basically, it's a function that goes easy in one way, but not easy to reverse. And we can actually use a simple sum function as an example to demonstrate a cryptographic hash. So let's say I ask two members in the audience to give me two random numbers. One would be like, okay, 6. And someone else would be like, how about 4? Or maybe 3. Okay, 3. So I'm going to say, okay, cool, I'll put this with my hash function, and I'm going to add it up, and it's going to be 9. It's very easy, right? Cool. So this is actually not easy to reverse, because if I tell you, hey, my hash function is the sum function, and my result is 9, I cannot definitively tell you what were the two numbers people gave me initially, unless I already know it. So that's a simple example of a hash. And this is a really dumb example. You will never use a sum function to hash things in real life. So let's scale this up just a little bit. Now, imagine transactions are no longer something complicated, and they're just simply numbers. And now we can start adding transactions together using our cryptographic hash function, which is the sum function. So, okay, I have 3, I have 6, I'm going to get 9. And let's say I receive 2 more new transactions into my box. And just waiting for animation here. Okay, let's say I get 2 and 5 as the 2 new transactions, and I add them up, and now I get 7. I can also use a hash function, which is the sum function, to add up these two, 9 and 7, and get a final result. And that would be essentially the Merkle root in our case. In the case of a block on a blockchain, the cool thing about the Merkle root is that it will uniquely determine the transactions contained in that block or in that box. So the next part of how blocks chain is that we need to understand this idea of a block header. So imagine you're trying to move, from one city to the next, and you have a bunch of boxes. What would you do? Sometimes you would, write the contents of the box on the lid, so you know where to put them, and etc. Right? So block headers are similar in that idea. A block header contains a string that's basically a concatenation of a bunch of information, and the key parts are the Merkle root of the transactions that's in the current box, aka the box that's like just being closed on top of the entire stack of boxes. And it also contains the block hash from the previous block, aka the hash of the block that's directly underneath this current blocks that we just closed. And there's some other information, and there's a random number called announce. And what we do with this is that we put this to the SHA-256, which is a publicly known and widely available cryptographic hash function. We hash it twice, and it will give us a random string of number, which we call the block hash or block header hash. And it will typically look something like this. There's it's basically a series of strings and characters and numbers. So typically, if you're mining, what you do is you change the transactions in the box you're trying to close, and then you change the random number, and your goal is to get a high number of leading zeros, like the part I'm highlighted in green here. So sometimes you require 8 zeros, sometimes you will require 7 zeros, and this is not easy to happen. So what you do is you keep changing the number of transactions, the different transactions that you're trying to put into the box, and you keep changing the timestamp, and you keep changing the random number. And if you do get the right number of leading zeros, and this is literally a trial and error process, then you can basically be rewarded for it. And we'll talk about that a little bit later. So once again, how do you add blocks to the blockchain? It's exactly like stacking boxes on top of one another. And because each block that's recently being hashed and being closed and has a lid on will contain a reference to the hash of the block directly underneath it, we essentially form a chain. And this is, once again, the blockchain. The cool thing about this is that you can start from any point in the blockchain that you know to be true, and you can travel forward and backwards in time to see if everything adds up. If the cumulative result is not correct, then you know something is wrong. So let's go back to our running example here, and we'll restart the animation. So this is the previous example. We hashed the block, and it's a new block, and we got a block header of, we got a Merkle root of 16. This is block header 1. So let's make a more expedited process. Let's say the next Merkle root for the next block is 14. We'll do that here. Yeah, let's say I just close the new block, or I just close the new box, and the Merkle root is now 5. Cool. So I can basically say, hey, you know what? 16 plus 14 plus 5, I should be getting 35. Just waiting for the animation to catch up. Okay, cool. I should be getting 35. But if someone's telling me, hey, my result is like 34 or something else, not 35, then I know there's something going on, something's wrong, someone's trying to, not tell me the truth, and I need to go back and verify everything. So that's how we have a blockchain. So previously we talked about the key characteristics that's very cool about blockchain, which includes decentralization, transparency, and immutability. And what exactly does it mean, and how is it achieved by using a blockchain structure? Well, it's decentralized because anyone who's interested, miners, just simple node owners, can listen to the new transactions. All they need is a sufficiently, basic, powerful enough device, like a smartphone or laptop, and a connection to the internet. So they're able to listen to any new transactions, and everyone's going to use the same algorithm to package and verify the blocks. So it's decentralized, anyone can do it. When a block is hashed or packaged, the person that was able to package the block will basically broadcast the result to the entire network and say, hey, I heard the same new set of transactions, or somewhat the same set of new transactions, and this is the newest package of transactions. Here you go, guys. And then because everyone's using the same algorithm, everyone who hears this new message of a new block is going to be able to verify by pretty much the entire network to see if the result is correct. So like how cryptographic hash functions are easy to go in one way, if you know all the inputs, it's very easy to see if the result is actually correct. So everyone checks. And if the result is correct, as expected, then everyone approves of this new block, and then the miner who initially packaged the block will be able to get paid. So miners will essentially rinse, repeat, and try to generate profit from doing this process over and over and over again. So this is why blockchain is decentralized. It is transparent in the sense that anyone can download the entire history of the blockchain and go backwards or forward in time and verify all the results yourself. You can verify the transactions, you can verify the block headers, and it is purely transparent. And the last thing is immutable, in the sense that history cannot practically be changed. So for you to be able to, insert a new transaction or change a transaction somewhere that happened in the past in the blockchain, you would have to basically unstitch the entire blockchain, change that transaction, and then rehash everything and put all the pieces back on top faster than anyone can verify or generate new blocks. And that's really hard to do. You would essentially need at least more than 51%. Well, you need to be able to overpower at least 51% the computing network of the computing power of the entire network to be able to do that. And that is statistically impossible. So this is why we say the blockchain is immutable. So what about anonymous and trustless? Basically, this is the idea that for me to do business with you, I don't need to know your identity. I just need to know that you are who you claim to be. And this idea of knowing your kind of without knowing your identity, knowing that you have ownership to certain assets is actually quite powerful. So basically, we need to verify that you own assets, and basically, we need to know that there's you have no economic profit to gain from cheating. And this is a simple idea of, let's say, I'm able to somehow get more computing power and subvert the network and start changing transactions on the blockchain. People are going to start to realize that, and the value of the assets on the blockchain will start to decrease because there's no longer any trust. And therefore, I'm basically shooting myself in the foot after doing a lot of work. And that doesn't necessarily make sense. So here in the slides, I included a video that kind of explains the idea of how you can achieve, this verifying who you are without knowing your identity using easy color mixing analogy. I'm not going to play the video now, but I encourage you to look at that afterwards. So let's talk about how you can get involved as a developer. A lot of my friends are JavaScript developers, and they're like, oh, it's so cool. Blockchain is really interesting, really exciting. You can do a lot of good things, but I don't know how to get involved. It sounds really complicated. And the matter of fact is, it really isn't, because the simplest thing you can do is start to look at open source repos and start to contribute. I myself contribute to the Dash ecosystem repos quite a lot, and I also work on Ethereum smart contracts, and it's really a very welcoming open source community. And the best part is, a lot of these blockchains have implementations in major languages, including JavaScript, right? So later on, I'll provide a link to a video where I walk through how to use JavaScript to essentially generate public and private key pairs, starting from a random string, which is called a mnemonic. It's kind of like a password. And how to get some dash or test crypto from a service called Faucet, and how we are able to create transactions, sign them, broadcast to the network on the testnet, and see the transaction on the net eventually being confirmed. So let me briefly explain the idea of a testnet. Because cryptocurrencies have value and it's sometimes very expensive, for example, Bitcoin at the moment right now is nearly $3,000. It's going to be really prohibitive for developers to even try to make apps that send transactions, because that will require you to have some Bitcoins, and not everyone has that kind of money to play around with. So all of these cryptocurrency networks will essentially build a replica of the real network, running on the same technology, the same algorithms, but using fake money. So kind of like monopoly money, and you can request some of this monopoly money and use it for development. It has no real value, but it's valuable in the sense that as a developer, you can play around with this monopoly money, just fake Dash or test Ether or fake Bitcoins until you're confident your app works, and you can now launch it into the real network. So let's talk about, if you're not a developer and you're an investor and you think this is going to be super cool, it has great growth potential, how do you get started? First step is to get an address. And it literally does not require anything to get an address. So all you need to do is download wallets. There's two that I personally use and I recommend, and these have really great simple UI and it's not confusing. One's called Jax and one's called Exodus. Jack is an app and also a Chrome extension that you can download. They're actually a Toronto-based startup, and they're really cool and they work really hard. So try that out. And the other one's called Exodus. Exodus is a I guess computer laptop-based application that you can download, and they also have really good UI. And the next step is, okay, I have an address, I have a wallet, I have something that I can hold cryptocurrencies, and that's super awesome. But how do I actually get some cryptocurrencies? There's actually two major ways. One is that you can open an exchange account. Exchanges are places where you can exchange fiat currency, for example, USD Canadian dollars, and buy cryptocurrency. So Coinbase being an example of exchange. They will have different transaction fees, different KYC or AML requirements. So do your research, find one, open an account. It might take a while, but once your account is open, you can now exchange fiat currency for cryptocurrencies, and that's how you get cryptos. Another way, if you don't want to go through the hassle of like verifying your social insurance number, providing ID, waiting a long time, is you can ask your friend. Be like, hey, I would like to buy some Dash or Bitcoin or Ethereum from you. Are you willing to do that? You guys agree on price. You give that person your address, which comes from your wallet, and you give them the payment, and they will just send you the cryptocurrencies, and boom, you're done. And here's a couple of tips on how to stay safe, because for a beginner, it's kind of scary, and you're really concerned about losing this new asset. You may or may not be familiar with how it works and all of that. So here are the key things you need to know to stay safe. One is never share your mnemonic. So that's probably like a 12-word key phrase that you were provided when you opened up your wallet, or you provided yourself. Don't share that, because if you have access to this mnemonic, they can basically take control of your account, and you will lose all your assets. The second is to never share a private key. So same idea as the password. Never share it. Keep it safe, and don't keep it too safe that you yourself cannot find it or recover it again. Because you hear these horror stories of people who had like bought some Bitcoins when it was really cheap, and then they had this password written down somewhere or saved on a notepad on the hard drive, and then later on they realized, oh my god, Bitcoins are so expensive now, and that's like whatever I bought before for like a couple $100 now worth a lot of money. So, but then they don't remember how to get access to their accounts, because they don't remember their private keys, or they don't remember their mnemonic, and they just lost a hard drive, so they have to go dig through like their basement, trying to find a hard drive, trying to get their keys back. That's a lot of work. Don't be that person. And the other thing is, try to diversify your holdings, and also diversify where you stash your crypto assets. Diversification is important in the sense that if you just buy any particular coin, it's going to be super volatile, especially if you're buying a low market cap coin or some kind of ICO. But if you buy a bunch and you have basically a basket of cryptocurrencies, as a class, it's volatile, but it's going to be a lot less so, and it will be less risky for you. The second thing is, store your assets in different wallets, even hardware wallets, and store them in like separate places, and keep your keys in separate places. Because let's say one of your wallets gets compromised, or you lose one, private key, you don't lose access to everything. So these are just good security practices. And lastly, it's more like from an investment perspective, because I used to be in finance. I kind of like have to give you this advice. Only invest in money you can afford to lose, in the sense that it's going to be super volatile in the short term. Even though I personally am very bullish on this asset class, in the long run, like in the short run, there's no telling what might happen. Regulation could change. There might be bans. There might be hacking or security events, and the value might crash to something quite low. So if you cannot afford to lose the money, you probably don't want to be investing heavily in cryptocurrencies, and only invest money you won't need for a while. So if you're able to buy it and hold it for a long run, and be able to ride the short-term lows and highs, you will have a better probability of generating a better return on investment. And lastly is, enjoy the ride. It's going to be crazy, it's going to be wild, and that's actually part of the fun. So be okay with that and enjoy the process. So this kind of brings us to the end of this presentation. What's next? Like, what's going on? Well, a lot of really cool things. It's literally the best of times, the worst of times. We had 2 forks in the 2 biggest like cryptocurrencies. There might be another fork coming up for Ethereum because of the switch to proof of stake. But it's all very exciting. Well, for one, you can start building apps with smart contracts on Ethereum or even on Bitcoin. And that's going to be super cool because there's not a lot of people doing that. This is new technology. It's like you being the first one to build Flappy Bird and putting it on the App Store. It's going to be awesome. Second is, if you're a developer and you're curious, just contribute to open source, right? We're always looking for good developers to join the team and learn about this technology and have fun with it. And if you're academic or you're into cryptography, you're into mathematics, you're like you're like number inclined, join a project and help the blockchain scale. This is honestly the biggest existential crisis kind of like for this technology right now. So that would be super awesome. We need all the help we can get. We need all the smart people working on this. And I'm personally really excited about what happens when you combine the blockchain and AI. And there's a lot of crazy things going on with ICOs. So let's briefly talk about ICOs because this is important. I know it sounds a lot like IPOs. It's only one other difference, but it's actually not even close and like completely a different beast. If I were to make an analogy, it's actually closer to a Kickstarter project on the blockchain. So what does that mean? It's kind of like if you're buying into a Kickstarter, you're not guaranteed any of the economic benefits this ICO is, kind of offering. And even if the ICO is bought into by many backers, some reputable investors, some venture capital firms, some leaders in technology, and a lot of like individuals, it doesn't mean this project will succeed. It can still fail for execution reasons, for technology reasons, for regulation reasons. So just because it has a lot of popularity doesn't necessarily mean anything. And also, if you want to invest in ICOs, the best advice for you is to do your research and actually look for projects that are solving real world problems with the right technology on the blockchain. So do your research. So if you really like the project, you like what they're trying to accomplish, you believe in the team, you think this is a great use of blockchain technology, then maybe consider investing, right? So we actually have a couple of good examples here. There's a troll example called the useless Ethereum token. So if we click on this link, basically the backstory is, I like this logo here, it's basically a guy that investing in ICOs and started to realize that, this is really kind of like fraudulent. And there really isn't that much transparency. So he basically built this website to kind of like make fun of this whole ICO phenomenon. And I think it's actually very well done. It's very educational. So I highly encourage that you look at the site. And if he actually launches ICO for UET, useless Ethereum token, I would invest because I think it's educational. Second is a real example. This is called the basic attention token. Some people call it a Brave attention token because it's basically the same people that was behind the Brave browser. But you can click on the link and read about it. But the gist is that they were able to raise more than $35 million in under 30 seconds, and that was like really wild. So I think this is actually a token that's trying to solve a big problem of how broken the ad exchange system or digital advertising is right now. So I think this is actually a cool project. Another more recent example is Filecoins. Filecoins is basically a way to have distributed storage of data. It's essentially a distributed database based on the blockchain. And they took a more regulated or more structured approach to their fundraising. So they raised about $200 million in under 60 minutes. And they used a vehicle that's based on the YC SAFE. So it's called a SAFT. It's a simple agreement for token offering. And they also worked, basically did the whole system similar to AngelList. That's called CoinList. So looking through them as well, this is a relatively successful and well-run ICO. And there's a lot to be learned. So that's pretty much it for my screencast. I included some resources in case you wanted to learn more about cryptocurrencies. And there's a couple of meetups that's specific to Canada or Toronto because that's where I'm based. And if you need more resources, if you're working on a cool project, if you need technical help, feel free to contact me or Slack me. Sorry, not Slack me, but email me. So email this address if you have a project you need help with, and we'll see what we can do for you. And if you're just interested in general technical discussions, email me at this address. This is my personal address. Cool. I hope this was beneficial for you, and yeah, hope you have fun.